Hello guys, welcome back to my channel Code Monger. So today we are going to solve problem 592, that is fraction addition and subtraction, right? So let's go through the problem statement first, right? So given a string expression representing an expression of fraction addition and subtraction, return the calculation result in string format. So basically we'll be given fractions, right, with both positive and negative symbols. So like calculate the fraction, similarly we have to do that and return the final result. Now there are certain few things that are given, like the final result should be an irreducible fractions, like it should be like both numerator and denominator are not able to divide more further, right? So that should be the smallest possible fraction that we can have. Okay, so if your final result is an integer, change the format of fraction that has a denominator. So let's say we got a result, right? Let's say 2. So in order to return the result, we should make it as a fraction and make it as 2 by 1. Okay, so that it forms a fraction. Now, what are other constraints? The constraint given are 0 to 9. Input string would contain 0 to 9, right? Uh, divide symbol, plus symbol, and minus symbol. Okay, and each fraction has the format of this, right? Plus minus, numerator, divide, and denominator. So if you look at it, there are 4 component: plus minus symbol 1, numerator 2, divide symbol 3, and denominator 4. If the first input fraction or the output is positive, then plus will be omitted. Okay, so in the given, if the given value, right, like in this case the first fraction that you see it is positive, right? So that's the only exception when it will not have a positive symbol. Otherwise, if the first one is negative, right, or if a plus is coming in between, then definitely it will have this plus symbol. Okay, so that's exception where you can say when the first fraction in the given expression is positive, then we won't have a symbol. Same goes for the output also, right? And the input only contains valid irreducible fractions. So the input will also be irreducible fractions, where the numerator and denominator of each fraction will always be in the range 1 to 10. Again, if you look at the range, right, so it will be all would be one digit except 10. So 10 could be, 10 is the only one which is two digit, right? So in this case we also have to handle. If the denominator is 1, it means the fraction is actually an integer in a fraction format defined above. Okay, so that's clear. The number of given fraction will be in the range of 1 to 10. Okay, the numerator and denominator of the final results guaranteed to be valid and in the range of 32-bit integer. Okay, yeah, so I hope that was all the problem. Now let's understand with the help of example what they actually mean and how we are going to solve it. Okay, so the first input that they have given is minus 1 by 2 plus 1 by 2. So it is minus 1 by 2, right, and plus 1 by 2. So first we'll just try to see how we would have done it in mathematical terms. So as you can see, right, so the LCM of both the denominator, right, is 2. Simply we could have, this is actually a wrong example. These are just going to be if you do it mathematically, right, so plus half minus half, the answer would be 0, right? So in our case it would be 0 by 1 that we have to return. Okay, why we have to do this? Because it's been asked in the question to make it in the proper fraction format. Okay, so let's take another example where we are able to calculate something. Let's take second example, minus 1 by 2 plus 1 by 2 and plus 1 by 3. So here also minus half plus half would remove and the result would be 1 by 3. So again not a good example. So let's see the third example, 1 by 3 minus 1 by 2. Okay, so here we can do something. So 1 by 3 minus 1 by 2. Okay, so now if we have to solve it, right, so what we have to do is first of all find the LCM or the lowest common multiple of these two denominators, right? And in our case, if there are more fractions, then we have to find out the LCM of all the denominators. But just to keep things simple, right now we are considering two fractions only, okay? So the LCM of 3 and 2 would be 6, okay? Now, to further do it, further solve it, how we will do is we will divide this LCM that we got, right, with the first denominator. So that would be 3 when 3 will divide 6, so we will get 2, okay? So 2 minus 2 when 2 will divide 6, we will get 3, right? So our final answer in this case would become minus 1 by 6, right? So that's what our answer is, okay? Now so before we go forward, right, so one thing we figured out that for all the fractions we have to figure out the LCM of all the denominators. So how to calculate the LCM? So the formula of LCM actually is LCM of a comma b. If I want to find out, right, it would be equal to a multiply by b, okay, and the GCD of a comma b, right? So with that, with this formula, right, basically what we have here, with this formula we will get the LCM, okay? So that's one thing, we'll keep this in mind and we'll further use it in solving a problem, okay? Now so this is what, just looking at the problem, what we have to do, we understand how we are going to solve it. Now another challenge that's more predominant in this problem is processing the input that they have given, right? So the format in which they have given, if we consider it, we have to do some pre-processing first of all to have it in a way that we are able to actually use it in the code, right? So to do that, right, how I did it, I will discuss that and we'll see how we can actually do it, right? So let's take an example. If the input given is 1 by 3, right, let's take the second or the second input, let's take minus 1 by 2. Right now I'll write the expression as we have been given in the problem, right? So because you have to do some character processing here, so it would be clear to you, all of you. Then we will have 1 by 2, okay? Then we will have plus 1 by 3, okay? So if you see, right, as it was also mentioned in the problem here, like each fraction has the following format, right? So if you see here, there are 4 components. One is this signed character, second is numerator, third is this divide symbol, and fourth is this denominator, okay? So if you look at this expression, right, so here we have 4 components, here we have 4 components, and here we have 4 components, right? So if we want to generalize, right, so we can say every fraction every fraction will have these 4 components, okay? Now what could be the possible exceptions, right? As it was again mentioned in the problem statement, like if the first fraction, right, is positive, in that case we won't have uh, the plus symbol here, okay? So let's say as in the third example, the input given was 1 by 3, right, minus 1 by 2, right? In this case, if you notice, right, so here we have only 3 components, rest all of the fraction following it would have 4 components. So this is one of the exception where if the first fraction is positive, we will have only 3 components, so we have to handle this case separately, okay? So this is another case. Now what else is in the problem that while going through the problem statement that we noticed that could be an exceptional case? That would be if the digit that is coming here, right, it can also be 10, right? So most of the digit that they have mentioned is 1 to 9, right? But there is 10 also. So it could be possible like some values, let's assume it value could be minus 10 by 3 plus 2 by 1. Okay, this is just a random example that I have taken to just want make you understand the use case of a double digit could also be there, right? So 10 could also come here, right? So we have to keep this in mind also, like if we are doing character by character processing, so if we are at I, right, so whether I plus 1 is a character or not based, so how we will do that, basically that I am telling you. So if we are processing this character I, right, if its next character is also a digit, so in that case we will have a use case of 10, right? Otherwise, like if the if we are here, right, let's say now I is at 0 and the next character is not a digit, right, then it's a simple processing based on whatsoever the conditions that we have, we can process it. But again, this is a second exception when we how we have to handle 10, right? And this is the first exception, like where we have the first character as positive, first fraction as positive. Okay, and this is the second exceptional case. Okay, so we have covered up till now. Okay, now another thing is like in the problem statement that they have mentioned, right, that we have to return the result in the irreducible fractions. Okay, so how we are doing it is like we have to return the result in the irreducible fractions. So how we will achieve that, basically first of all, right, we are going to calculate the solve the problem like we have solved here, right? Mathematically we are going to solve the problem here in this manner. If we are able to do that, right, so in the end we will get some fraction here, some result here. Now it could be possible that this result is not in the smallest fraction possible, like irreducible fraction it is not. Okay, let's say it could be after solving it, it came out to be 10 by 5. Okay, so this 10 by 5, right, it's not actually the irreducible fraction. It can further be reduced to 2 by 1, correct? So this 2 by 1 should be our answer. So at the end of the problem, we also have to keep this in mind, like once we solve it at this way, right? The mathematically, if we solve the problem, the fraction that we'll be getting can be not, it can be in the not best irreducible fraction. So we have to make it the to the form of irreducible fraction. Then we have to return the answer. Okay. So how we will do that? It's basically like as you can see here, what I had done is like we will find the GCD of both the numerator and denominator that we got here. Okay, so if you see here, if what I had done is the denominator and the numerator, if you find out the greatest common divisor, okay, and divide both the values with it, then you will get the final result. So what I mean by this is like if this was our value, okay, in our case 10 and 5 we got, and we know it is not a best, it is not in a irreducible fraction. Okay, so what to do? Find out the GCD. Okay, find out the GCD of 10 and 5. So if you find out the GCD of 10 and 5, so what is the greatest common divisor in 10 and 5? It would come as 5, right? With this 5, if you divide 10, you will get 2. If you divide 5, you will get 1. So that will be our final answer, and that's how we will reduce it to irreducible fractions. Okay, so I hope that this is clear, right? Now, so I hope, yeah, at least this part is clear. Okay. Now, if you look at the problem statement, right, the moment we got the expressions, okay, so I'll explain that also how we are going to process it. So, if we got an expression, right, we will check character by character, like what sort of thing. So, in order to do or apply this approach of mathematical approach, right, first of all, we need to have all the numerator and denominator. So what we did here basically is, first of all, we have all the denominators, right? All the denominators, and we need to segregate out, first of all the numerator and all the denominators. So until unless we don't have that, we won't be able to find the LCM of all the denominator, that is 6 here, right? So first thing is to separate out both the numerator and denominator, and then okay, so I will also note down, right? Separate out denominator and numerator. Okay, separate out denominator numerator from the given string. Second step would be to find the LCM of all the denominators. Like, once we have done that, then third step would be, so once we have this, right, so then what we do, we divide this LCM, right, LCM we found in the second step, we divide that with all the numerators. So the value that we got in the second step, we divide it by the numerators. Okay, and we then just add all of them, we add them. Okay, so basically that's what we are doing here. So we do 3 divide 6 divide by 3, whatever the value got, we written it here, right? Then again 2 6 divide by 2, whatever the value we have got, we have written it here, right? 3. Now this how we will by default we will only do additions, so where we will store this negative value, right? In case we have to do this, right? So this value comes from here only, from the fractions itself. So while processing the string, right, if the value comes out to be negative, if the first character, right, it is negative, so in the numerator itself we will store it as -1. Okay, and if it is positive, in the numerator we will store it as 1. What I mean by is this, so let's try to process this, at least this one, how our uh, numerator and denominator array would look like, right? So we will have two arrays, numerator and denominator. So since the first we are here right now, if the first character is negative, okay, so we will store -1 in the numerator. Then if it is divide, we will skip it. Then and meanwhile we will also check, right, whether it is a 2-digit or not. It could be like -10 can also be there. So what we will do, first would be a character, right, by default, because that's the fraction. So first component we will handle this exception case separately, but for generalized case, this is how we are going to do it. So the first character should be a sign character. So if it is, we will check that. If it is negative, then it's fine, right? Then we have to multiply our answer with -1, so that whatever the numerator value is stored as negative. Okay, so after the signed character, we will go to the next digit. We will check whether that digit is a single digit or 2-digit, right? So if it, in this case it is a single digit, so we will add it as so we will do here multiply by 1, right? So the value would come as 1. Okay, so just to simplify it, I'll just remove all the calculation that we had done, right? And I will put in the numerator array as 1. So this is our first value, -1, sorry, this is our first value. Then there is a divide symbol. After that, again we'll check whether it is a 2-digit or not. If it is not, so after the divide value, whatever we got, we will put it in denominator. Okay, so -1 goes to the numerator, 2 goes to the denominator. Then again we got a character. Okay, so here it is a positive, so that means we don't have to multiply it with -1. So we will simply store the character following it into the numerator without multiplying it with a -1, and we will check also whether it is 2-digit or not. It is not a 2-digit, so we will store it as it is. Then there is a divide symbol. We will skip it because it represents fraction. Then after the character following the divide, we'll check whether this character is this digit is a 2-digit or not, right, by checking this character and the character following it. So the character following it is positive character, it is not a digit, so we know that it is a single digit number, and we'll store that in the denominator. Okay, now we will come again this is a positive character, so we don't have to multiply the digit following it with -1. So in this case it would be 1, and we will check whether this is 2-digit not, since it is not, because it's the character following it is a divide symbol, not a digit, so we store as it is in the numerator, right? Then we will go to the last character here after divide symbol. The divide symbol is simply skip, right, because we don't have to any processing there. Then after that we will have 3. We will check whether it is since it is the end of the character, right, if we do I plus 1 here, we will get index out of bound exception. So the last character anyway we have to ignore, because it will be after divide, if there is only one character right coming, so it will be a single digit only, so we will store it as here 3. So this is how our numerator and denominator array or list, whatsoever you want to store it in, it will look like this. Would be our numerator and this would be our denominator. Now the same thing after this we have to follow for all the denominator. If you find the LCM, it would come as 6, correct? And then if you divide the second step as we discussed here, right? First step is to store the numerator denominator. Second is to find the LCM of denominator. Third step is to divide all the LCM that we have found in the second step with the numerators, right? So let's do that. So for all the denominators, right, so 6 divided by 2 will get 3, it would be -3, right, and we'll simply add all the values, right? So 6 divided by 2, the value would be +3. Okay, then 3 divided by 6 divided by 3, basically it would come as 2. So these two value would cancel out. The final result we would get is 2 by 6. And to evaluate the final solution, we have to find out the GCD. The GCD of 2 and 6 would come as 2. So the value would be 1 by 3, right? So that would be our answer. Okay, so that's how we are going to evaluate it. Okay, so I hope everything is clear by now. So let's move to the coding section, how we are going to code it. Since this is a very verbose problem, right, could be things like if I write it, few things can be missed, so I have written it beforehand. I'll just walk you through the exact thing that we have discussed on the right side, so that you will have all the clarity of how exactly we are doing it, right? So as I have discussed, right, so first of all we are going to have two lists, one for numerator and second for denominator. Okay, now this is actually the first exceptional case, right? In this case, as we are discussing, when the first first fraction is positive, right? When the first fraction is positive, in that case, we will only have 3 characters, so there is a little bit thing different. So when the I is equals to 0 and the first character is not first fraction is not negative, right? That means it is a positive fraction. So in that case, what we have to do is, right, we don't have to multiply it with -1. Okay, so that's what we did. And other than that, there are certain common things I'll just cover. Like if you see in all the conditions, right, we are checking whether I plus 1 is less than expression dot length. So why we are doing it? It is because, like, we are not at the last character, because we have to check the 2-digit, right? So here basically what we are doing is we are not at the end of the expression, and the second character of from where we are at currently, right, from the ith position. If the I plus 1 is not a digit, right, if the I plus 1 is not a digit, then we will come to this else condition. Okay, so we will just directly have to add that character as an integer value in the numerator. Okay, and if that's not the case, then we have to find then we have to add two characters, right, both at current I and I plus 1, because both of them will contribute to the two digit value, right, because let's say 10 comes, right, so in that case we have to first we'll check the digit 1, right, and the character following it that it is 0. If that is also a digit, we will add it to the numerator as 10. Okay, for rest all of the things it will come here as a single digit value in the numerator we will add. Okay, then here we are doing I plus plus. That's basically because we are skipping the divide or fraction expression, right, and that divide symbol. Then after that, what we have is, again we have to this condition wherever you are seeing, right, so it is basically we are checking for 10 whether we have a two digit number or not. So if it is two digit number, then we have to add it as two digit, otherwise it is a single digit. So that's what we are doing, right? So this was the exceptional case of the first fraction is positive, rest all it would be same, rest everything will come in the else, like for all the remaining fractions except the first one. So there we will always have those four values. Okay, so in that case if the fraction comes as negative, then in the numerator we will storing, if the fraction is negative, right, then we have to store the numerator as negative value, right? So that here is that's what we are doing. We are multiplying it minus 1 and then storing. The first case is when two digit or 10 comes, and the second is for all the single digit. Then again in the numerator, we are after the numerator is processed, we are skipping the divide, and then we are processing the denominator here. Okay, this is for the negative fraction. Similarly, we are doing for the positive fraction. Only difference is here we have to multiply it with minus 1 and then store it. Here in this case we don't have to do that, we simply have to store the numerator because they are positive. So here two use case, for one for handling 10 and other for handling remaining values. Similarly, after that we are skipping the divide, right, and then we are processing the denominator. So here in D, which denotes denominator, we are storing it. Okay, now as we discussed in the problem, so up till now what we have done is like some pre-computation to storing all the numerator and denominator in proper array list so that we can actually process them. The next step was to find the LCM. Okay, so I was using Java. If you want, you can write a separate function for finding the GCD, right, and all those things, but I had used the inbuilt library, right? So and in Java there is not straightforward operator to calculate the GCD on the integers, so that could only be done on the big integers, so I have used that. So to find the LCM, as we discussed here, right, the formula of calculating the LCM is a multiplied by b divided by GCD of a by b. So for all the values in the denominator, right, we have to calculate the LCM. So that's what I did. I defined the initial LCM value as 1. Okay, and then I keep one by one I have picked up the values from the denominator and keep on updating the LCM by finding the LCM of all the pairs, right? So that's what I did. I got the LCM of all the denominators, right? Okay, and then converted that, since this value was in LCM, so I got a denominator by converting it to the int value from big integer. Okay, so up till now we have got the denominator. Now we have to calculate the numerator also. So how we did that is as I was just discussing here, right? So once we have found this value 6, in that case, then all the denominator, this denominator would be divided by all the lower value of the fractions, right? That is the denominator of the fractions. So that's what we are doing it here. We are iterating over all the fractions, the LCM value, right? Basically this was the LCM value. So this LCM value is divided by all the denominators, and then that value is multiplied by the numerator, and we are just adding it in the value. Okay, so this these numerator and denominator will represent our final answer. Okay, so hope up till now everything is clear. So next what will happen is, like, we will create a numerator. We will check if the numerator is 0. In that case the result would be 0, but to make it fraction we have to return 0 by 1. Okay, now as we discussed in the problem, right, it could be possible that it is not the value that we got is not in the irreducible fraction. So we have to do that, and how we did that is actually the calculating the GCD of both the numerator and denominator, and then dividing both numerator and denominator with this GCD value, right? So uh, okay, so here I have writ so what we did is, like, to do that again in Java we have to convert it to big integer, right? So both numerator big integer, denominator big integer, I have converted them, right? And then we calculated the GCD of both the numerator and denominator, right? So here I had written LCM, this could be actually GCD, right? So here we have calculated the GCD, then we found out the GCD value, converted the GCD big integer value into the int. Okay, and then finally we divided the denominator with this GCD value, right? The common high GCD value of numerator and denominator, and the numerator with the same value, right? And then finally both our numerator and denominator will be in the smallest form, right? And that's what we simply have to return. Okay, so this was the whole problem. Like, from length point of view, I think this unnecessary expressions, all these that we have to write, right? If you are come up with the regex during the interview, then that, I think that would be a bit challenging. At least it was for me to come up with the regex, but if you're able to do that, you can actually do it like that way also. So this is actually the main challenging part. So once you are able to write it down, rest everything is like what we do, how we calculate mathematically, right? So that's all what's being translated into code and being represented here. So I hope, like, this problem is clear to you, and the solution that I had provided is what I was able to come up with. So I hope everything is crystal clear to you, and if there is any problem or if you have any questions, ask them in the comment section. I'll be glad to answer. So yeah guys, that was all from my end. See you in the next video. If you like the content, do subscribe for getting more future content like this. See you in the next video.